Hello, good morning.
Good morning, sir.
Is it audible?
Yes, sir. Yes.
Shall we continue? Shall we continue?
Yes, sir. Yes, sir.
In the last class, we have discussed about stress. What is meant by normal stress, average stress, and we have obtained the expression for change in length. That is deformation. We have discussed our principle of superposition. We have solved a problem. Let's solve this problem. We will go ahead and look into the further problems for the few varieties of problems. 'The problem statement is like this: a brass bar having uniform cross-sectional area of cross-section of entire brass bar. I will write the figure also. The brass bar having a uniform cross-sectional area of which is equal to 300 mm square is subjected to load as shown in below. Find the total elongation of the bar and magnitude. Find the total elongation of the bar. What is the total elongation of the bar? DL total is equal to what? And magnitude of load P. What is the magnitude of load P? If Young's modulus C is given to be as 83 GPa, 83 into 10 power 9 Newton per meter square, or 83 into 10 power 3 Newton per mm square. The problem is like this. Twenty kilonewton, 10 kilonewton. It's continuous. A, B, C, D, 500. Sorry, 500. You may want to let me write once again. That got erased. Okay. Okay, I will write it once again. Give me a moment. No, given a problem like this, how do you solve? In the initially, what will you do? What will you do if a problem is given like this? What will you do initially? I don't know force P. What will you do initially? Anybody? What will you do? How will you go ahead? Anybody?
Divide it into three parts. We'll keep it as
Okay, we'll
P, A,
divide it
B.
into three parts. That's fine. We'll solve that. That's fine. But how many equations we'll get in this type of problems? How many equilibrium equations we'll get? What is the equilibrium equation? Summation of forces in x direction is equal to 0 is the only equilibrium equation, so that we can find only one unknown. Only one unknown. So what I will do before starting this problem, when there is the unknown force given, you can directly solve this like this. What you can do? Summation. Give me a moment. Okay, you can do uh, summation of forces in x direction is equal to 0. Summation of forces in x direction is equal to 0 minus p plus 80 minus 20 minus 10 is equal to 0 minus p plus 50 is equal to 0. P is equal to how much? 50 kilonewton, right? This is the magnitude of P. P is equal to 50 kilonewton. Now simplify the problem. Now I will take a section. Here. I will take a section XX. I will write the figure, free body diagram. P, this is P of AB, which is equal to, I can write summation of forces in x direction is equal to 0, which means that P of AB minus P is equal to 0, or P of AB, which is equal to P, which is equal to 50 kilonewton, or P of AB is equal to 50 kilonewton. Hope you understood this. Okay. Next segment will pass. Next is, I'll take off of this. I'll write 50 directly, 50 kilonewton, and there's a section here, and this is 80 kilonewton load. I will take a section here. I'll write it here. XX 80, in which direction? 80 kilonewton. 80 kilonewton. It's acting like this. 80 A B. I'll get away from this PBC. According to my formula, according to the equilibrium equation, summation of forces in x direction is equal to 0. I can write it as summation of forces x direction is equal to 0 minus 50 plus 80 plus PBC is equal to 0, or PBC is equal to 80 minus 50, 30 minus 30 kilonewton. PBC is equal to minus 30 kilonewton. Next segment will go. Next segment, we'll take a section here. XX 80 20. P is 50. At descent is 80 kilonewton load acting. And then 20 kilonewton, 20, A, B, C. This is PCD. The internal resistance force acting away from the body is positive. The acting away from the cross section is positive. This is the convention what we have assumed. PCD acting away from this cross section is assumed to be positive. So if I take summation of forces in x direction is equal to 0, or minus 50 plus 80 minus 20 plus PCD is equal to 0, or 80 minus 50 is 30, 80 minus 70, or PCD is equal to how much? How much? Minus 10 kilonewton. Minus 10 kilonewton. PCD is equal to minus 10 kilonewton. Okay. Now, what we have to do? We know that deformation total is equal to deformation in AB plus deformation in BC plus deformation in CD, which is equal to P of AB, L of AB, PL by area of AB, Young's modulus of AB plus P of BC, length of BC, area of BC, Young's modulus of BC plus P of CD, L of CD, area of CD, Young's modulus of CD is the deformation total. But in this problem, since what he has given area and Young's modulus of the entire this brass cross section brass bar is same. It is area at 300 m square and Young's modulus is 83 mGPa. So since area is in mm square, I will be expressing my Young's modulus in also in mm square. Okay. I'll take common. I'll write for your convenience. 1 by A into E, which is equal to P of AB, L of AB, plus P of BC, L of BC, plus P of CD, L of CD, or I can write it as deformation total, which is equal to 1 by 300 into 83 into 10 power 3 into P of AB is how much? How much? P of AB is equal to where we have found this either it's P or I can write in this section where this is P of AB. P of AB is 50 kilonewton. P of AB it's 50 kilonewton. 50 into length of AB. Length of AB is 500 plus P of BC minus 30 and minus 10, right? P of BC, I'll write it here directly. Minus 30 into 1400 minus 10 into 1000. Can you tell me what is the deformation total? Right? Is this clear? You tell me what is the deformation total. Is this clear up to here? Same type of problem what you have done yesterday. Only thing is we have found the unknown force by using the equilibrium equation, which was previously known in the previous problem. There are no unknowns, but today we have calculated unknown force and we have solved the problem. Tell me what is deformation total? Are you calculating? Shruti,
minus
observe.
1.84.
1.08, sir.
1.08. What is the unit?
Sir, mm, sir.
Yes, mm. We are calculating everything in mm, area in mm square, stress in Newton per mm square, and then Young's modulus in Newton per mm square. So deformation, what we'll get is also in mm, 1 is 1.08 mm. So the bar is under compression. Due to this combination of load, the bar is under compression. 1.08 mm compression. Okay. Okay, this is about the first problem, second type of problem. Next problem will go ahead. This I want you to parallelly solve with me. The axially loaded composite rod shown in figure has a uniform cross-sectional area of 500. The bar has a cross-sectional area of 500 mm square. Determine the change in length. Determine the final change in length. The modular of elasticity of steel, Young's modular of elasticity in the sense Young's modulus. Elasticity of steel is 200 GPa or 200 into 10 power 3 Newton per mm square. Modular of elasticity of aluminum is 70 GPa, 70 into 10 power 3 Newton per mm square. Modular of elasticity of copper it's equal to 120 GPa. 120 GPa. This is the given problem data. We need to find a total deformation. The problem is like this. $30 kilonewton, 80 kilonewton, 50 kilonewton, copper, aluminum, steel. Okay. Now, how do you go ahead and solve this problem? So before that, what you can do in this type of problem, you can find the reaction force if you want, or you can also solve by without finding the reaction force. But this always is better to find the reaction force and you can solve the problem. So what you can do, you can take as you will follow the same procedure. You will find the reaction force. Summation of forces in x direction is equal to 0. Therefore, you assume a reaction force. I don't know the direction of reaction force. For time being, I will assume the reaction force to be in this direction. However you want to take, in the whatever sense you want to take, you take reaction force here. If a reaction force is positive, some positive value, say positive 50 kilonewton, then it is acting in the same sense as you assumed. If it is minus 50 kilonewton, then it is acting opposite to the direction which you assumed. So let us find out. So my RA, it's minus 50 minus 30 minus 80, sorry, minus RA minus 30 minus 80 plus 50 is equal to 0, or minus RA minus 110 plus 50 is equal to 0, minus RA minus 110 plus 50 is how much? 60, right? Minus RA
Yes, sir.
equal to 60. RA is equal to minus 60 kilonewton. RA is equal to minus 60. Is this right? Right?
Right, sir.
minus 60 kilonewton. So it means that you don't worry about the sign this direction. Whatever the value you got, you take in the same value. But for your understanding, I'm telling you. Therefore, it means to say that this RA is not acting in this direction. What you assume, it is acting in the opposite direction. RA is acting like this. But in the problem, you take whatever the value you obtain. I will tell you what does it mean. So when you're solving the problem, the first section I will take, the first part I will take. This is RA. However, you obtain, take in the same sense RA. Okay, whatever we want only the magnitude and the sign RA, and then P of AB acting away like this. P of AB. Okay, RA is equal to minus 60 kilonewton and P of AB like this. So I can write summation of forces in x direction is equal to 0. Therefore, this is RA is minus RA is minus of minus 60. Are you understanding this? Give me a moment. RA. Okay, minus of minus 60 plus 1 ನಿಮಿಷ ರೀ. Give me a moment. Let me think. That's fine because this is fine. If I would have been taken RA in the positive sense, that is 60 kilonewton. If I would have been taken RA as a 60 kilonewton, then minus of minus will be plus 60. Therefore, whatever you assume, minus of minus 60 plus plus PA plus PAB is equal to 0. Therefore, PAB is equal to minus 60 kilonewton. That's right, no? PAB
Yes,
is
sir.
equal to minus 60 kilonewton. Okay. If you would have been taken in this sense, for example, if you have been taken RA as in this sense, positive sense, then PAB plus that whatever that 60 kilonewton, then it would become minus 60 only. Have you understood this? Is there any confusion?
Yes, sir.
No, it's
No,
right
sir.
only,
No,
right?
sir.
Any doubts?
Yes, sir.
Right.
Right only, right?
No, sir.
RAB, my
Right, sir. Right.
PAB is like this. RA is acting away from negative x direction. Minus of minus 60. This PAB is minus 60 kilonewton. Next. RA only I will take. And then this is 30 given in the problem. A, B, C. Sorry, I can't write C. A, B, P, B, C acting away from the body. I can write summation of forces in x direction is equal to 0. I can write this will be minus of minus 60, minus of minus 60, minus 30, minus 30 plus PBC is equal to 0, or PBC is equal to 60 minus 30. It's 30 minus 30 kilonewton. Right? Minus 30 kilonewton. Next section we will move. RA 30 80 A B C. My internal force acting away from the cross section is positive. PCD. I can write summation of forces in x direction is equal to 0. Minus of minus 60 minus 30 minus 80 plus PCD is equal to 0, or PCD which is equal to 110 80 80 80 90 110 110 plus 60, how much? 50 50, and then it's 50 kilonewton, right?
Plus 50 kilonewton.
Plus 50 kilonewton. PCD it's plus 50 kilonewton. Okay, that's right. That's right. Okay. Now deformation total, which is equal to, shall I write directly? I'll write for one more problem. Deformation in copper, aluminum, steel. Copper plus deformation in aluminum plus deformation in steel, which is equal to, now it should be conscious. P copper, L copper, area of copper, Young's modulus of copper, plus P aluminum, A aluminum, area of aluminum, copper, area of aluminum, plus Young's modulus of aluminum, plus P of steel, area of steel is at PL by A. DL is equal to PL by A. L of steel, area of steel, Young's modulus of steel, PL by A. Okay. Now I can write P of copper. P of copper is how much? This portion AB, it is also equal to,
Minus 60.
P of copper is also equal to minus 60 kilonewton, minus 60. P of aluminum is equal to minus 30 kilonewton. P of steel, which is equal to 50 kilonewton. Okay, minus 60. Okay, minus 60 into length of copper, it's 500. Area of copper, its area remains the same, 500 mm square for all the material. Young's modulus of copper is given as 120 GPa, 120 into 10 power 3, plus P of aluminum, it's minus 30, plus minus 30 into length of aluminum, it's 700. Area of aluminum remains the same, 500. Young's modulus of aluminum given in the problem, 70 GPa, 70 into 10 power 3, plus P of steel, it's 50 kilonewton. I have missed 10 power 3. I should include 10 power 3, 50 kilonewton, 30 kilonewton, 50 into 10 power 3 into length of steel, it's 300 by area of steel remains the same, 500 into Young's modulus of steel, it's 200 GP. 200 into 10 power 3. Cancel 10 power 3 and tell me the answer. Deformation total is equal to in mm. Find that you can take out in the denominator common.
minus 0.95 mm.
Minus okay, moment. DL2. What is your name? What is your name? The person who answered now. What is your name? ಯಾರು ಆನ್ಸರ್ ಮಾಡಿದ್ದು? The person who answered now, who is that? Who is that? ಹೇಳ್ರಿ
ಅಲ್ಲ ಸರ್, ನಾನೇ ಸರ್ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಕ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ.
ಹೆಸರೇನು?
minus 0.95 ರಾಘವೇಂದ್ರ ಸರ್.
Okay, correct answer. Minus 0.95 mm. So bar is under compression. Minus 0.95 mm. Therefore, deformation total is minus 0.95 mm. Okay. You can also solve this problem. You can also write it as deformation total. Deformation total, which is equal to 0.95 mm compression. You can also write the problem can also be solved in the other way. You can also take the suction from here. So this will avoid this confusion, reaction force. You can also take suctions here. You can also start taking the suctions which I have not indicated. If I have taken the suction from here, I have taken the suction from here, and then here second suction, third suction. But if it's confusing for you, you can directly take the suction from here, first suction, second suction, third suction. The reaction will not come into picture at all. So therefore, this 50, there are 50. Then P of steel will be obviously whatever that 50 kilonewton. P of steel is equal to minus 50 kilonewton only. Is it minus 50 kilonewton? Sorry, 50 kilonewton. P of steel will be, this is 50 kilonewton minus P of minus PST plus 50 is equal to 0, or PST is equal to 50 kilonewton. Similarly, if you take this, this is 80 minus 50, and then 30, and this will be acting like this, minus 30 kilonewton, whatever P of copper, whatever the value you will get it. Okay, and then this one, then finally can take a section here, and you'll get a 30, 80, 80, 80, 50, 80, 80, 90, 100, 130. Now whatever this is, 80, 80, 90, 100, 130, 130. This should be how much? Sorry, 80, 80, 90, 120, 110 minus 50. Similarly, you'll get minus 60 kilonewton here. Okay, this is how you can solve the problem. Either you can take the section from left hand side or right hand side, whichever you feel comfortable, you solve it. Generally, I followed the convention of finding the reaction force first and then solving the problem. But in case if you find difficulty or confusing, then you can solve it by taking the section from the right hand side also, whichever is convenient. But the method which I followed is absolutely right. The reaction force what we found out was minus 60 kilonewton. One minus of since the RA is acting towards the left hand side, according to my sign convention, the forces acting in the positive x direction is positive. Okay, the forces acting in the negative x direction, or negative force is negative. This is positive force. This is the convention which I followed, and then minus of minus RA, which would be this minus of minus 50, whatever we got, minus 60 will be plus 60, and RA P of A will be minus 60 kilonewton. So by this I completed one more problem, two problems today. Next class we will solve few more types of problems, and then another 3, 4, 5 classes I should be able to complete this this part, that is your boss part. Next we will go to that Poisson's ratio, volumetric strain, other part of this model that can also be completed in the online class. Okay, hope you understood this. Any doubts, any difficulties?
No, sir.
Yeah, have you understood this?
Yes, sir.
Yes, sir.
Yes, sir.
Please tell me the attendance who are all present for today's class. I'll call the names, you tell me your USL. Give me a moment. Abdul Razak, What is the USN?
Present, sir. Yeah, 001.
001.
1.
Okay. Next. Dhruti?
3, sir.
Sir, Chetan, 2.
Okay. Next. Mekala?
Sir, 08.
Okay.
Hello.
Okay. Next.
Sir,
Pratish Paul? I3
Sir,
Chetan.
009.
What?
Pratish Paul 009, sir.
Okay.
USN.
hello. Sir,
Yes.
Chetan, 02, sir.
I3. Okay. Next.
Oh.
ನಿಮಿಷ. Raghavendra? Your USNs are there, right? 10. Okay.
Yes, sir.
10.
0 0.
You're with your USN. Okay. Umesh, you should write type your USN with along with your name. Okay, I'll make
Yes,
just
sir.
give me a moment.
18, sir. 18.
Okay, I'll take a screenshot of it. Okay, thank you. Any difficulties or doubts, you can contact me. You can message me, or in the next class, you can ask me. Okay, thank you.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.